Okay, we are here and we are looking at section 7.3 today, and it deals with more multiplication properties of exponents. So hopefully by the end of this lesson, you could say I can raise a power to a power and I can raise a product to a power. So the first question you may be asking is, what does all that mean? Well, a power of a power would simply be this. For instance, I may have the quantity x to the third raised to the second power. So what does that actually mean? That would actually mean x to the third times an x to the third. So with our property from yesterday, when we have the same base, we could simply add those exponents, which would mean I would get x to the sixth power for a final answer. So likewise on the bottom, if it says the quantity 4 squared to the fifth power, that really means 4 squared times 4 squared times 4 squared times 4 squared times 4 squared. So if we use our property from yesterday, it would really mean 4 to the 10th power. So the question becomes, what's the easy way to do it? Well, for a power of a power, if you look at these two exponents, the 3 and the 2, to get to the 6, we can simply multiply. And likewise, the 2 and the 5, if we multiply those, well, we would get to the 10. So that would be the power of power. So what do you want for a rule? If you wanted to write a rule, you would say something like this: multiply exponents. Okay, so that's the first one, power of a power. The next one is known as power of a product. So now we've got the quantity 4x to the third raised to the second power. So what does that mean? That would mean something like this: 4x to the third times 4x to the third. So really that is 4 squared times x to the sixth, or 16x to the sixth. If we look at the second one, this would really mean 4m to the fourth times 4m to the fourth times, or excuse me, I should be saying 5m to the fourth times 5m to the fourth times 5m to the fourth. So what does that really come out to? It's 5 to the third, m to the 12th. So what is 5 to the third? 5 to the third is 125, m to the 12th. So what is the pattern here? Well, if we take a look, it really means, like for instance on the first one, that this 2, the exponent applies to the 4 and it applies to the x to the third. Likewise on the bottom, the 3 would apply to the 5 and it would apply to the m to the fourth. So what would be my rule here? Maybe something like this. You may want to write it as exponent applies to everything in the parentheses. Okay, so let's look at some examples of these two. So the first one, I've got v to the fourth to the second power. So that would be, we simply multiply these two, so I get v to the eighth power. You try the next two, and we'll see how you do. Okay, so you should have gotten an a to the 35th for this one, and we should have gotten an n to the negative 24th for this one. The only thing is, you shouldn't stop there, because we know negative exponents aren't proper, so I rewrite it as 1 over n to the 24th. That would be my final answer there. Okay, for this next one, first thing I deal with is these exponents here. So I've got this h, and then I've got an h to the 30th. So an h times an h to the 30th really is an h to the 31st. Okay, for the next one, I've got x to the third to the 2/3 power. So that would be x to the second. And then the y to the third just stays there. Okay, the next one is that first one, or excuse me, the first example where we have a power of a product. So this exponent of 5 applies to the 3 and to the q. So I really have 3 to the 5th, q to the 5th, and 3 to the 5th is 243. So I've got 243 q to the 5th power. Okay, a few more examples from this slide. So for the first one, if we use that power of a product, or excuse me, power of a power, I would get a to the 24th, and here I get b to the negative 10. So to simplify that, so you don't have a negative exponent, it would be a to the 24th over b to the 10th. The next one, if we take a look here, we multiply these two sets, I'd have m to the 6th and n to the 0, which really just is m to the 6th power. Okay, we're going to skip number 9. Why don't you give number 10 and 11 a try, pause the video, and then come back and see how you did. Okay, so first of all, this is how I'm interpreting this problem, a k to the negative 9. So if that's the case, then I would have a 5 to the negative 3 power and a k to the 27th power. So when I simplify that, I'd have k to the 27th over a 5 to the 3rd, which really is k to the 27th over 125. Okay, the next one, the 3, that exponent applies to both of those things. So I should have 3 to the 3rd and s to the 12th times an s to the 2nd. Well, 3 to the 3rd is 27, and s to the 24th, or excuse me, s to the 12th and x to the 2nd, we got the same base, so we add those exponents, so we should have 27 s to the 14th. Okay, this last one, if we just apply that exponent out to both of the things on the inside, I'd have b to the 1/6 and a c to the 1/2. Okay, a few more. Now, if I try to apply this to scientific notation, it applies directly. So, for instance, if I have the quantity 4x to the 3rd to the 2nd power, that really means I'm taking 4 squared and then 10 to the 3rd squared, which would be 10 to the 6th. So this is really 16 times 10 to the 6th. And then if you remember, I need to move that decimal over. So that becomes a 1.6 times 10 to the 7th power. Okay, we are going to skip number 20. Why don't you jump to 21 and 22 and see how you do. Okay, so if you use a calculator and take 1.4 to the 3rd power, you should get 2.744, and then it would be times 10 to the negative 24th. That's what you should have gotten for that 21. Okay, if you do it for this next one, number 22, 5 to the 3rd times 10 to the negative 21st, and 5 to the 3rd is 125 times 10 to the negative 21st, and then we start moving our decimal. So I move it twice here, so that means this has got to change by 2, and since this one got smaller, this one's going to have to get bigger. Okay, so I'd have a 1.25 times 10 to the negative 19th power. Okay, I think we'll leave it at that. Skip to the next two. We'll jump to these two word problems. So the first one, we're dealing with a cylinder. We got the radius of 2.9 times 10 to the 5th inches. The height of the cylinder is 3.8 times 10 to the 4th inches. We want to find the volume. Well, we can simply use the formula. So we got a pi, and then we got times 2.9 times 10 to the 5th. That whole thing is squared because that's the radius. And then we got to take it times the height, which is 3.8 times 10 to the 4th. So if we follow our order of operations, we would have to take the that middle one, 2.9, that whole quantity squared. So 2.9 squared is 8.41. So really I have pi times an 8.41 times 10 to the 10th now. And then I still got 3.8 times 10 to the 4th. So if I were to multiply these things out, I use my pi key, so I got pi times 8.41 times a 3.8. So that would give me 100. And if I round, it would be 100.4. And then times 10 to the, if I look here, I got 10 to the 10th and 10 to the 4th. That would be 10 to the 14th. So now, if I move my decimal place 2 places, This number got smaller. This number has to get bigger. So that would become 1.004 times 10 to the 16th, and that is inches cubed. Okay, so for this next one, find the area of a square. We simply take the side length squared. So I have 2 or 5.9 times 10 to the second. If we square that, 9.5 squared is 90.25. So we got 90.25 times 10 to the fourth power. So we move it once. This has got changed by 1. So I got 9.025 times 10 to the, let me change that, times 10 to the, that one got smaller. This one's got to get bigger. So it'd be 10 to the fifth power. And this would be centimeters squared at this time. Okay, so hopefully that is making sense to you. That's all I have, so that is a wrap.